Hello everyone, my name is Prerna Rawat and in today's discussion we are going to discuss high performance computing. So it is very interesting topic and important topic as well. So first let's talk about the importance. Why it is important? Because right now you are seeing so many applications, you are seeing so many things like driverless car, you are seeing object detection in real time, you are using GPS for route, you are going somewhere, you are finding route, if your path is blocked, you can reroute your car or vehicle, you can get the output, you can change all these things, you can get the output within a minimum time, means you can get the next route or alternate route within a minimum time when you are searching for the next route. So that kind of application we are developing, and what is the reason? Because of high performance computing. This program is going on without, means there is no need to send a human, from the remote location you can give the instruction to the robot or to the software that you have developed, and you can perform the task. So all these things we are achieving just because of high performance computing. And why it is interesting? Because everybody wants that kind of things. Suppose if you are watching a movie on Netflix, you will see the list of movies, right, based on your interest. If you are shopping on online platform, you will get the item list based on your search, based on your interest. So everybody want that kind of application, everybody want to develop, and you are a software engineer, then definitely you will develop that kind of application for the users. So that's why it is important and it is interesting. Now think about the high performance computing topic. If you are dividing that topic into two parts, high performance means you are increasing the performance, and computing means number of operations, number of mathematical calculation. So you are doing so many number of mathematical calculations within a minimum time. Means in other words, you are processing large amount of data and you are getting output within a minimum time, because you are performing, you are completing the task within a minimum time, then only you are getting the output. If you are not able to process the data completely within a minimum time, then definitely you will not get the output. But that thing we are achieving just because of high performance computing system. So we will talk about this in today's session. Here are the content for today's discussion. First we will discuss about the introduction of HPC, then HPC challenges we will see, how does it work, then parallel computing, one more important topic of HPC. Because of parallel computing, we are able to achieve speed. How? We will see in today's session. Then importance of parallel computing and some use cases we will discuss in today's session. Then I have prepared one assignment that you have to complete after today's session. But before starting the HPC, here you have an idea some module. Why? Because in HPC system there are three things. First one is the compute node. Second one is the network. And third one is the data storage unit. So if you want to develop HPC, that means these are the three things. These are three building blocks to build a HPC system. And one by one we will discuss how these components are related to this. So why I am saying microprocessor idea you should have, because this microprocessor will give you idea about the processor, means computing node. What kind of processor are there, how they will compute, what is the speed of microprocessor. If you have a 3 GHz processor, what does that mean? Means it can calculate 3 billion operation per second. It can perform 3 billion operation per second, right? So likewise you should have idea, and this idea you will get from the microprocessor module. Second, principle of programming language. Definitely you will build something, because you are a computer engineer, you will build some software for particular application. So for that, how you build a well maintained, well structured programmable code or software. So for that you should have idea about the principle of programming language. Next one is system programming in operating system. This module gives you idea about a scheduler. Why scheduler is important? Because in HPC what you will do, suppose if you have task T1, task T2, task T3, and if you have processor P1, P2, P3, okay, and you have again task T4 and T5, right? So you have so many tasks and you have so many processor as well. But what task you will perform first, how you will arrange the task in order, that idea you will get from the scheduler, and that idea will give you SPOS module. Now computer architecture and organization, this component of this module give you idea how hardware components are connected together to form a system. So that idea you will get from this module. That's why you should have idea about this module, and I hope in previous year, in first year or in second year, you have studied that module. So it will help you to learn HPC system. Now we will see about the introduction. So HPC has an ability to process the data and to solve a complex task. So you can process large amount of data. How? Because in HPC you have what you have so many processors, you have so many computing units that are connected together, and you can process the large amount of data, and you can perform complex computation as well. How perform complex calculations? Because the one problem you are dividing into small parts, and these small parts you are giving to different processor at the same time. So you are speeding up the performance and you are solving complex problem as well. That's why it is HPC. So HPC has the ability to process the data, to solve complex problem, and how? Because it is a aggregation of computing power. And what? It is a main discipline of parallel computing. So parallel computing is the main key point to speed up the process, because what you are doing, you have so many tasks, you have so many processors, and you are giving task to this processor at the same time for execution. You are not performing task one by one. You are performing or executing so many tasks at the same time. That is parallel computing, and that we are doing in HPC system. Now my question is, in related to parallel computing, what thing is critical in parallel computing? So see the answer and please give me, see the option, and give me answer. Think about it. Here we will talk about the HPC challenges. So HPC challenges: fixed infrastructure, long wait, and delay innovation. Suppose in HPC system, basically we are developing for solving complex tasks. We can process large amount of data within a minimum time. That's why we are developing HPC system. So what are the challenges? Suppose if you have a large amount of data, and that data if you are executing or if you are processing with a fixed infrastructure, okay, so this is a challenge basically with the HPC system, because you have to wait for a long time for output, and if you are waiting for a long time for the output, that means your research, your innovation will be slowed down. So these are the challenges with HPC system. And how we are moving, because we can customize HPC system. You can build your HPC system based on your requirement, based on your application. Now you can build it. How it works? So as I said earlier, HPC system has three main components: computing node, network, or data storage. So here in this picture you can see you have a computing node. These computing node you are grouped together and you are forming a cluster. So these are the cluster. And in a cluster, every node is connected to each other with network, and they have a storage unit also, so that they can feed and digest the data also in real time. That means if you are building a HPC system, so everything will work with the pace to each other. If one thing is failed, suppose if the network connectivity is failed, if the computing node is failed, if the data storage unit are not able to feed or digest the data with a real time, that means your HPC system will be failed. So everything will be work with a pace to each other. Then and only you can get the output within a minimum time. Now we will see here in particular computing node what we have. We have operating system, we have a processing unit. So in every computing node usually we have 4 core process unit or 4 core unit. And storage also we have, so that we can feed and digest the data, share the information. We have a network connectivity between each node so that they can communicate to each other. Now we will talk about parallel computing. So first we will discuss about that picture. Here in the Formula 1 car, you can see here everyone is working together. Someone is filling the fuel, someone is fixing the tire, someone is checking the error, and they are fixing together. So this is parallel processing or parallel computing. If you are talking about computing, so here what you will do, instead of person, you have so many CPUs. to execute the task. So likewise we are creating a parallel computing and we can solve so many problems at the same time. And how? Complex problem, what you will do, one problem you are dividing into parts and you are giving to different processor to execute. See in the picture in next slide. Suppose you have a one problem, right? And you want to calculate employee data. So what you will do, that big problem you will divide into number of instruction you are giving to the processor. Okay, so this is not a parallel processing because you have a one processor, you have a one problem and you are executing instruction one by one. Suppose this is the data related to employee 1, number of hours, working rate, printing checks and text. Again same data you have for employee 2, same data you will execute for employee 3. Then you will think how much time we will take to execute the task. In parallel computing, what we will do, the same problem we will divide into independent small parts, and these independent small parts again we will divide into number of instructions and we will execute by the different processor. Employee 1 data by processor 1, employee 2 data by processor 2, and likewise we will perform parallel computing. So definitely you will get the output within a minimum time. Here are some questions based on parallel computing. First question basically asks to you, in a multiprocessor system that communicate with each other using what? Means in a parallel computing system multiple processors are there, but how they are communicating to each other. Okay, and my second question is, what is the principle to determine computation latency or communication latency between two nodes? Okay, so many nodes are there, then how you will determine the communication latency? So here are some questions. This is a tricky question, but you just think about it, definitely you will get the answer. Now this is the importance of parallel computing in HPC. You can save in time memory, you can solve large problem, and reliably, efficiently and quickly you can solve the problem. So in the discussion we have discussed already how parallel computing work and how we can save time and memory. Here are the use cases. In artificial machine learning application, you can see like object detection, driverless car, space organizations. So many programs are there. They are related to machine learning and artificial intelligence. Research lab, so many scientists are doing innovations and research, right, for innovating something new. Then medical treatment. In this medical treatment, like you can perform the operation, you can give the instruction from the remote location. By using expert system, you can perform the treatment or operation. So likewise we are using application medical treatment also of HPC. So these are some use cases. And here is the quiz. Whatever we have discussed in today's session, I have prepared that quiz. So please solve and let me know if you have any doubt. Thank you everyone.